We're going to be downloading Java, installing it, configuring it, doing a couple of things like that. First things first, go to oracle.com, click on the menu, then Products, followed by Java, and finally Java SE. Towards the bottom of the page, you're going to see something says Download Java SE for Developers. Let's click on that link. Here we have our Java JDK version 11. That's what we want to download. So we're going to click on the Download Oracle JDK. Scroll down a little bit and click on the agreement. Click on the, like I said, click on the Accept license, and then we're going to download the Windows version for 64-bit. Once downloaded, we're going to right-click on it and Run as Administrator, and click Yes to install it. We're going to start by clicking on the Next button and everything else. So we're going to install every feature, all features. This feature will be, and all sub-features will be installed on the local hard drive. Let's do that. Same thing with the developer tools. Click that and click Next. Once the installation is almost done, you're prompted with this, and you click on the Next Steps. Choose a browser. It's going to give you a documentation URL that you use in troubleshooting or creating JDK or Java Development Kit items and features. A lot of nice features, a lot of nice information in this documents URL. After that, we click the Close button. Now open up a command prompt and then change directory to the directory that it's installed on. For instance, in our case, ours was installed in the C drive, Program Files, Java, JDK 11, and finally bin. Once in that directory, you type the command java --version, and you're shown what version of Java you actually are running right now. You also want to type the command in javac or Java C, which stands for Java Compiler --version. And that tells you the version of the compiler, the Java compiler you're running. In our case, it's version 11. In the next video, we're going to be writing our first Java program. In this lecture, we're going to write our first Java program. On your desktop somewhere, open up a Word document, rather a text file document. We're going to go to a website called geeksforgeeks.org, and it's going to be in the show notes. This is what we're going to be using for our code to create our first Java program. So we created the notepad, actually saved it as helloworld.java, and we placed it in the bin folder of the JDK. The reason we did that is because the Java compiler is present there. The only other caveat is that we have to actually run as administrator the command line interface for it to work. You'll know that you're in the right place because if you type in JAVAC and you tab it over, you're going to see the program. If you don't see that, that means your program, your Java program, is not in the right directory. So we're going to compile the Java program by typing in javac.exe or just javac space, then the name of the program. In our case, is helloworld.java, and you can tab it over. Once we do that, you're going to see another file called helloworld.class appear here. Now let's run the program. So how we do that, we're in the same directory, the bin file. We're going to type in Java, okay, followed by the name of the program, hello.java. In our case, we could probably just do without the .java. Yes, correct. It works perfectly now. hello world.java, you would use that if you're using a Linux box. In our case, we just typed hello world and we saw the output. Therefore, our program is working functionally and is great. The next thing to do is to create a variable. So a variable is nothing more than a message. There's also something to be said about having the variable not be the same as some of the Java keywords in the Java language. Usually a variable starts with a letter, a $, or an underscore character. So let's actually write a variable. Same thing holds true where we have our program, which is something like, in this case, it would be something like first variable dot Java, and then the compiler would compile that, and then you should be able to, or you will be able to, run that program now in Java. So we're going to create a new text file and call it first variable.java and input our data. You'll notice here that the first variable, the first letter in each word is capitalized. They call that camel casing. So we're going to start by putting in our class information. We're going to declare our class name. In this case, it's first variable. Put curly brackets. So just to recap from other previous videos, this is your class. This, well, actually more like this is your main method. And we don't see it, but the statement, which is meaning the output, comes after. So we're going to save this. And we're going to close it, and we're going to actually compile that program. Remember, when you create a program like something.java, you need to compile it, and then it becomes a program that Java can execute. So the command is javac.exe followed by your first variable.java. So the error we see here when we run the compiler command notes that we have a spelling error here. See that it says pt should be print. So we look at our program, our first variable.java, and we do see actually a code mistake. So print, I need to change that. Save it afterwards, close it up, and we'll run the compiler again. Second code mistake, the print in actually should be print line. So we're going to change the I to an L in both cases and save it again. Run our compiler once again, and we see that we have a first variable.class located. So now we're going to run this program in Java to see if it works. So we've compiled the program in Java. Now we need to run it in Java. In order to do that, we're going to type in java.exe followed by first variable. And excellent. Our program runs excellently. We're going to be creating data types. So let me explain what a data type is. Let me just click on this variable here as first variable. Okay, data types are character, char, it's like a single line of code, string, this right here could be considered a variable right here, or I'm sorry, a data type if you will, actually. The integer, that could be, I don't see an integer there, a float or a Boolean. So what we're going to do is we're going to create a notepad file called datatypes.java. That's our program, and then we're going to compile that program. We're going to put text in there, and then we're going to compile it, and we're going to run it as a Java program. We're going to identify our class. Again, camel casing, because the first letter is capital of the first word, and the first letter of the second word is capital. It's called camel casing. We're going to put our brackets in there. So this has defined our class. This is the class type or class. In here, this is our method. And at the bottom, you have statement or the output. Again, character or char means character. You'll notice that the M, instead of the quotations, that's just little, I believe they're called apostrophes. I believe these two things are called apostrophe, not quotations, followed by a semicolon. The semicolon indicates the end of that command is not the right word. Instruction would be more of the word I'm looking for. So let's break this down a little bit, shall we? So what you're looking at is your initial or the string title, or rather the character letter. The character letter is M. So that represents the letter here. The string title equals data types video for you. That's here, the title. The integer number, 365, in this case number, that's relative to here on the number here. The float decibel is relative, or looks at this decibel character here, or decibel output. And finally, the result is the result here. So it's all relative. So that's a little bit insight into programming in general. What you're seeing here is character letter M, letter being you're going to print out that, or you're going to show that whatever that is. So in our case it'd be M. So it'd be like M data types video for you 365 32.0 F Fahrenheit, and finally result or true. So when we compile this as datatypes.java, it's then going to create a datatypes.class file, and then we're going to be able to run the datatypes file or program in Java. And what you'll see is, again, you'll see the output of all of these present. So it's running a program consisting of this data. We're going to save this as datatypes.java and place it in our bin file. We're now going to compile that datatypes.java. So first load up our Java compiler, define our datatypes Java program, execute, meaning compile that data, and you are going to see that now you have a datatypes.class. The next thing is to actually run the Java program against that actual Java data types program. So exe, so it's java.exe, followed by data types. Okay, we're going to remove the .class, and your expected output again is going to be what you see here. You expect to see M data types video for you 365 32.0 F, and then true. In comparing the two, you see this now. Hopefully you're getting a clearer understanding of what exactly this is starting to do, meaning you're inputting data here. You're saying, okay, identify this data, then output on the screen after running a program, the Java program. This is what the representation of here is. So you know, if you had any errors, you would know that your Java program is not working. But since you don't have any errors, you can safely assume that it's working. Your Java program you've created is functional and is in good working shape. I would like to point out something. I would just make the note of this. Anytime you've defined your data types, such as your program datatypes.java, it's always a good idea to actually, when you name your class, if it's data types, all camel case, then you want to name your Java program, or datatypes.java in this case, you want to name it the same thing. The uppercase D and the uppercase T, meaning camel case. So that when someone else comes behind you and you're moving to another job and that person comes in, they can see that the class data types and the name, that was what it's for. It's just good practice to do that. In this lecture, we're going to create constants. So we're going to create a program called constants.java. A constants program, constants.java, excuse me. Constants are data that doesn't change, or information that doesn't change in your program. henceforth why it's called constants. Okay, so we're going to create a program called constants.java, meaning that's a notepad, and we're just going to name it constants.java and put some data in there. We're going to define our class. We're going to define our integers, our final integers, by using hockey standards. For instance, a hat trick is worth 3 points or 3 goals. A goal is worth 1, and assist is worth 1. So we've defined our method. Now we're going to define our output, or our statement, if you will. So the thing to remember here is what you're doing is you're declaring the integers here, right? So I'm declaring that HT equals 1 times hat trick. Goal, or GL, equals 1 times goal. AS equals 1 times assist. And so now you can factor in the total points. So you can play around with this basically. But your total equals hat trick plus goal plus assist. You could definitely play around with these numbers, play around with these integers, play around with this data. Might want to think about maybe in your scenario, perhaps putting something like final integer equals, or final integer stands for the, instead of hat trick, you could probably put something like hourly rate, or something like worked hours, and then integer could be something like days worked, or like this could be hours worked, and this could be like weeks worked, and this could be years worked. And so what you end up with is maybe a total could be something like maybe salary is your total instead of, say, point in this case. Anytime that you want to define something like some data in here to tell anybody what it is, you could put a comment, and you comment it by just putting a those two characters there, a forward slash, if you will, and then perhaps put something like constant, let's say hockey, right? And that the code is not going to read because it has the forward slashes at all. It's not going to read everything after that. Period. Let's put a period there. Any words can go here. The reason you do that is so that, again, your code is nice and clean. It tells anyone who's looking at it, this is what that code does. These are this is what the integers are. This is why I'm naming this. This is exactly what it is, what it does. So we're going to name this as constant.java. Excuse me, constants.java. So we moved the program into the bin file. It's right here. So now we run the compiler. We're going to compile constants.java, type java javac.exe, or just javac. Then you want to do constants.java. Oh, a bunch of errors. Okay. I know why. Because I didn't declare the integer here. I didn't tell it, oh hey, by the way, I need to identify the integers. That's what I didn't do. Yeah. So here I need to actually note the integers, meaning I need to tell the program, hey, these integers these are integers for this program. Now that I've declared the integers as HT, GL, AS, the program should work. Let me save it, and we'll run it again. Fantastic. Excellent. Okay, awesome. See how easy that is just to forget those little things like that in programs? Imagine if you had 100 of these you had to do, and the attention detail wasn't there. So let's do a CLS to clear the screen. And we're going to now, since we've compiled the program, now we're going to run it, actually. So we're going to run that program, and it's constants. Okay, constants, right? We're going to run the program. And the output is 5. Let's take a look at our Java program and see if that is the same. So points is 5. In our case, we had a hat trick, which is 1. We had a goal, which is 1. and we had an assist, which is 1, so that's 3 plus 2 is 5. If we change the characters right here, for instance, we had, say, 2 hat tricks, and we had 2 goals, and then you had, say, 3 assists, and you save the program, close it, and you run the program again. Seems as though I have to compile that once again, so let's compile that again and do it the same way. So we're going to compile that, okay, and we'll run the program again. Let's see here. So what is it, Java, okay. Right, we have a difference. So what that tells us is this. When you change the variable on the program, meaning you're changing the program itself, you have to recompile that program and rerun it, because if you don't, the values don't change. Thanks for watching this tutorial. In this lecture, we're going to create a math program in Java. We're going to call it math.java. That's our program. We're going to compile it, and then we're going to put some values in it. So we're going to first create our notepad with our class, our method, and our statement. First, we have to define our integers. We're going to do like a number, and followed by a factor, and then a sum. So after every statement, in this case, you must put a colon. That defines to the program, okay, I've completed this program, or I've completed this section, if you will, or this line of code. Okay, I completed this line of code, it stops, and it starts after the semicolon again. A good coder will a lot of times put descriptions in the code, such as defining numbers for a program, okay? And just to tell the reader or the other individual who looks at your code, this is why I did this, whatever that is. And to identify that, you put just the forward slashes into your code, so that way the program doesn't read it. You can also try this for I believe it is in math, called please excuse my dear Aunt Sally, which is parentheses, exclamation, multiplication, division, addition, subtraction. In theory, really, you could put the code along one line, but that is very hard to read from a human perspective. From a computer's perspective, it doesn't matter. But if I want to read that code and all of it's in one line, it tends to be very difficult to read and understand. That's why you'll see a lot of code written this way. If you've ever seen any of the other tutorials, you'll see them write code this way because it's just easier to comprehend. So for this program, you could have a lot more than just this as far as math is concerned. But in our case, we're going to just demonstrate a couple of different things. I would like to point out something though. Your class name and the name of your program should be the same name. If it's capital in your class, it should be capital in your program name. So now we compile our program, math.java. And when we run the program, our expected output, for instance in this one here, should be something like sum equals num plus factor, which is 52 in this case. This one would be 48. This one would be 100. This one would be 25. So we're going to run the program, and our expected output is I would like to point out also that this number, rather these values here, whatever you put in here, is irregardless. You can put anything you desire in here. As long as it's in the quotations, it doesn't matter. Same with this, same with this, same with this. The program doesn't care what this value is. It's just a description, that's all it is. If you wanted to clean it up, for instance, you say together, you put in your quotations itself, you put a space bar, and when you do that,
your output will be different. Let's recompile that and I'll show you what it looks like. Now you see the output is a little different, quite a bit different now, because we've put a space bar here in the quotations. Looks a little neater in your code or your program, if you will. Whereas I left the other ones here, the quote, the exclamation, the parentheses, there's no space. So that's why you see the value here. There's no space noted after together 100. Thank you for viewing this lecture.
In this lecture, we're going to be setting up a program called assignments. Assignments.java is the name of the program. We're going to do something a little different though. We're going to make it easier actually. So there's a program called Sublime Text. We're going to go and download that. So go on your favorite browser and go to Google, and type in Sublime Text. You type in 3 or Sublime Text, if you will. Open up the download icon or the download button there, and let's download it. Sublime Text, well, basically just make you a better programmer. Basically, here's what it looks like. It's free to download for Windows and Mac and other various OSs. And look at how nice it is with your code. You can just start tabbing things and type it in, and this is a representation of your code. Just very, it'll supercharge your code basically. So let's download that. We're going to click on download. Ours is Windows 64-bit, so we're going to click on that. And once it's downloaded, we'll double click and install it. Follow the screen here, GUI, the next deal, and everything next to install the Sublime Text. Finish. So we're going to open up Sublime Text. From here we're going to write our code. So the name of the program is called Class Assignments. So we're going to save it as Java. When you save it as a .java program, what it does is it'll change the names, or rather it changes the colors of the code. That's because you identified the name as .java. So once you put in your brackets, you put in just one. What it does is it puts the other one in. Look at how nice that is. Just start typing in stuff. It knows based on what it is, it knows, okay, I need to put in information. So you can start typing stuff in, and it'll basically finish typing in what you're typing in. This makes coding a lot faster and a lot easier because you don't have to type as much. Because it knows. Look at that. I just typed it in, it filled everything else in. That's so nice. I probably have to go back and I have to delete a couple things here, but you see it just puts information in that normally you'd have to type all that in. So we're going to finish putting information in assignments.java, our program, and then we'll come back. Okay, so now we have our assignments.java built, the program basically built. So the only thing I had to do is I had to change the super good. I had to put the quotations a little different in there than before. So these things here, like this plus equals, and this equals, and this plus equals, and the times equals, the divide equals. So again, we're going to save the Java program, the assignments.java. We're going to save it. That's our program. And we're going to compile it, and then we're going to eventually run it as a Java program. So it's been saved here. Let's put it over in our bin directory. So first we're going to compile the assignments.java. We're going to compile that first, and then we're going to run that program. So the code here, the output is going to say add and assign strings together. And so if we had, for instance, we had a space here or a space here, you would see them not merged together like that. Same thing with the integer here. Fact is that the integer sum is, it would be actually different. It'd be actually, there's a little space here where we have to put a space right here. We have to put a space there. The multiply 75 while that gets the factor in, you have the sum, meaning the sum, it's 15, so take 15 and the factor times 5 and equal 75. Conversely, here, when you have the sum equals divided by factor, you have 75 divided by 5 equals 15, and that's where you come up with that. These kind of programs, running this and playing with the numbers, playing with the actual data, is really critical in learning Java. So I'd like to thank you for viewing this tutorial. In this lecture, we're going to be creating a compare program in Java. You might remember from our last lesson, we installed Sublime Text, which makes it easier to create code. So I'm going to start by deleting all this stuff here, and I'm going to be creating a program called compare.java. So with this Java program, what we're looking for when we see like this equals to, it's true or not true, rather true or false basically is what we're looking for. So every time you should see the output, it should be true or false. For instance, how you read code, right? So for instance, string text equals super good. String lung or language equals Java. Boolean state equals test equivalent to long. So text super good is equivalent to Java, right? And then system out print line string equal test plus state, meaning it should say something like your output should be like string equals test plus true, or string equals test true or false. Same with the state equals test, and that little the bang equals, that stands for it's not equal. Basically this right here, this bang equals means doesn't equal. So does super good not equal to Java? Okay, so the state would be probably true. So they're probably going to say, what is this, false? And this is going to be true. Okay, so the other one is the integer. So you have integer dozen equals 12. So dozen, it represents the number 12. Score represents the number 20. So the state would mean dozen is greater than score. Okay, so basically your output should say, okay, more than this, that equals state. So this is going to be a false, and this one right here. And finally, this one's going to be a true, because less than, so dozen, 12, is less than 20. That's how you read that, by the way. So this right here would be true. So let's run our program, our compare.java program. First we need to move it in the bin file, and then we'll run it, or rather compile it. Now we'll just go run our compiler, so that's javac.exe, then we're going to compile it. So that's compare.java. Seems as though we have an error, so we have to go and fix that. It probably doesn't like the character, this character right here. Probably doesn't like that character, so let's remove that, actually. Let's save it again, and let's rerun it. Interesting. Okay. So I'm going to try something here. I want to do the same thing with these two strings right here. Actually, just do the one there. We're going to save it, and I want to show you what it looks like. So we'll do CLS, clear the screen, up arrow a bunch of times. So that's not it. Oh, I know why. Okay, here we go. I shouldn't have equal here. I should have plus. Or, yeah, I should have a plus symbol. Because, yeah, I should have a plus symbol. Yeah, that's right. Yep. See, that's the thing. When you're just dealing with code, you never know, right? It's good to, this is why the coders, anything like this, little mistake like that could just make it change your code completely. See, yeah, it made it better. So this, okay. So what that says is this: it doesn't matter if you have a space here. It doesn't really matter if you have the space after this quotation there. What matters is should have it defined like a plus state. Okay, so
we've ran the compiler, and okay, so let's take a look at this, right? So what we're looking at, the string equal test here, so that's false, meaning Boolean state. So text is equal to lung. Supergood is equal to lung, false. And that's why you got that false right here. If I can do it, okay? String not equal. So state, text is not equal to lung. So supergood is not equal to lung. Supergood is not equal to Java. And that's true. And then we have dozen 12. So 12 is greater than 20, which is false. So that's why we have the false here, And then finally, dozen is less than, so 12 is less than 20, which is true. So that's why we have this true statement here. So thanks for viewing this tutorial. In this next lecture, we're going to be writing a logic program. So it'll be logic.java. Let's start off by opening up our Sublime text and inputting our data. So we've named our program we've named our program logic.java. So we've defined our class, we defined our method, and our statements are system. This is our statement. So what these are, this and here, and the whatever that is, the break or whatever it's called, pipe if you will. So this and means logical and this two breaks means logical or, and this bang here means logical not. So let's compile this and let's run it, and then you can clearly see what we're talking about here. So we've saved it, logic.java, our program. We're going to compile that logic.java program. Okay, let's compile it. Excellent, and now let's run the program. So we're going to take off our Java compiler, remove the .java, and run it. Okay, so let's analyze this. You're probably confused already, right? Basically, like, what does all this mean, you know? So they use this for a representation of either a true or false. Like, think of it like a on or off, basically, in that regard. So this program would feed into another program, and it would do an action or do something based on this value. Like, if it's true, it does this. If it's false, it does that. So let's break it down. So Boolean, yes. So think of this right here. Think of this as saying true. That's all it's saying is true. And think of this no as saying false. That's all it is. So you have true and true equals true. You have true and false equals false. Right here. Right here. Right there. Okay. You have a true or a logical or a true. Oh, that's a true. Right there. Right here. That's a true. So that is true or true is a true. So you have the yes, no, so that means true, false. So true or false, that's a true right there. And then you have a false, false. So false or false equals a false. And then you have true. So that would mean just by itself is true. So that's true because there's nothing else right there. And then you have a logical not. So meaning this is like the reverse. See, this has the original and the inverse or reverse. So that means not true. So not true equals false, right? So that's why you get this false right here. These are very confusing probably to the first time you've ever seen it. And I know first time I've ever seen it, it's so glazed over eyes. But as you do it on your own and you just get the hang of it, you learn more about it. And the key is just to do everything I'm doing here on your own so that you fully understand Java.
So I'd like to thank you for viewing this tutorial. In this lecture, we're going to be actually creating an escape program. So it's going to be escape.java. Have you ever wondered if YouTube, some of the old programs way back in the day, they almost look like a dot matrix, basically printout of some data, maybe a report card or people in the classroom with their grades or their test scores for that particular test. Could even be a forecast for the weather. So that's what an escape is. Let's show you. So I've pasted the code in our Sublime text, but I have yet to save it as a .java. That's why it's you don't see the other kind of colors on there. So let's do that. That's much better. This is going to be a fun one. Let's start off by compiling our program. And compiled it. Oh, we have a bunch of errors. Okay, the reason why I get all these errors like the capital F here is because the string notes, okay, I'm a lowercase f, but here, and also here, the forecast, here you're telling me it's uppercase. Which do you want? So you have to name it the same as the string. So we've taken care of that. Let's save that. And let's rerun our program. Fantastic. Let's clear the screen to give you a little more real estate there. This time we're going to run the program. So watch what happens. Look how cool that looks right there, by the way. Isn't that kind of nice? Basically, it's like, okay, the Bismarck 7-day forecast is as such. It's Saturday, it's a high of 37. Of course, it's out of line. I probably need to clean that up. So let's take a couple of these off here. Save that. And then we will run it. Then we will run it again. Okay, so we're getting a little better. Moving it over a bit. Yeah, I think I know why. So I need to actually put a plus here. So I need to note that as a plus. So I need to add that in. Add these features in here. So I need to add it there. Okay, let's save that. Recompile it and run it again. I think I have that figured out here. So what I need to do is I need to actually perhaps let's put it here and let's save that. So what we did was, we're trying this out, by the way, we're just troubleshooting this. So we did the system out print line header plus forecast. So we've done that. Let's compile it again and see what we got. So it's been compiled, and then let's run the program and see if the value changes. Fantastic. Okay, great. So it looks like our code is a little off here. You probably notice the offset of the numbers here. So let's try to clean that up. Okay, first thing I'm going to do is I'm going to remove this system out print line. Let's remove that one. Let's save our Java and compile it again and then run the program. So it looks like you're back with square one. So I think I have it figured out. So on the last forecast here, I need to add a plus as well. That's why we were seeing a double when I did the system out print. That's why we saw two, because it stopped after here. So I put the system dot out here, and then it stopped it, and then started a new one. That's why we saw it. So we're going to save that. We're going to run, and we're going to save this. I want to purchase it right now. Thank you, Sublime Text. We're going to compile it and run it again. Okay, awesome. Works fine. Not so much though. We have these letters here. They're a little off-centered. We need to fix that. So we're going to play around with this. We're going to first choose Wednesday here. We're actually going to take off this tab here. So that's T stands for tab, by the way. Let's save that and let's rerun it. Excellent. Okay, so basically because we removed that tab, so a /T stands for tab. So let me just tell you about this. So a /T stands for tab. So you push the tab button, that's what you'll get. The /N here stands for new line. So it's a new line afterwards. That's why you see the new line as well. It's not on here, but the -B, which looks like this, dash or slash B. That stands for a backspace. The slash F stands for like a carriage return. I'm sorry, slash R stands for carriage return. So that's a carriage return actually, but that stands for slash R. Carriage return is like enter, right? That's carriage return in programming means enter. The slash slash means a backspace. The slash F means a form feed. And we already covered the slash B means backspace. So we're going to do the same thing we did on Wednesday, remove the tab for Thursday. Let's see here. I'm going to do the same thing for Thursday. I'm going to remove the slash T, which is a tab, and I'm going to remove the slash T for Saturday. I'm going to save it and then recompile it. There's one thing you should know, right? If you don't recompile, let's say because you just saved it, right? Save the information. It won't work. You can't run the program if you don't compile it first. So that's something you should know, by the way. Okay. Oh, looks great. Look at that. How clean that code is. Let's clean it up a little bit. Let's give it a nice. Show you that. That's some really good code, by the way. That's what I was talking about earlier when I talked about the dot matrix or the. If you watch a YouTube video, you'll see how the scores were, how when teachers used to post grades on the bulletin board, they'd get a printout from these type of computers back in the day. And you could pretty much play with this as long as you want. You could put any type of numbers in here. This is static. These are static strings. These are static numbers, static information. So you pretty much put anything you want in here, which is really remarkable. So essentially, you've created readable data from this. The ability to go here, you've created readable data. So I'd like to thank you for viewing this tutorial. Okay, in this tutorial, we're going to create a a condition program, meaning it's going to be condition.java, essentially. That's the name of our program. We're going to create a program, and we're going to compile it. So I've actually already created the program, condition.java, and it's still in the My Documents folder, and I have to move it over to the bin file. So let's just define what exactly is this condition, right? What does that mean? Let's actually just do it. Better than I explain it to you, let's just do it, and so I can show you exactly what all these things do. So we've already made our condition.java. We're going to push it over or bring it over to our bin file, and then we're going to run it. So let's just clear screen here, give ourselves some more real estate here. We're going to do java compile, G-A-V-A, C.exe, and then we're going to, what is this, condition.java. We're going to compile that, and we see we have plenty of errors actually on our program, and I think I know exactly what it is. So what Java does, if you ever run into this and you see an error, right, the little caret right here, it'll tell you what the problem is right here. It says, oh, this is the problem right there, right? Little caret there, that's the problem. So in this case, this little odd here, I need to move out instead of actually having the, let's see, instead of the colon, I need the two dots. That's what I need instead of the semicolon right there. And I'll need to change so I did this one, the odd even, that one. That's result. Number 2. Okay. Oh, it gave me 2 errors in the same one. Okay, fantastic, right? And then for the other one, number 2, so that negates, oh, right, same thing. I need to put the character here. I need to put the 2 dots there. Colon, not a colon, not a semicolon. I think it's a colon. Okay, it looks like we solved our program. We'll save it. And we'll rerun the program again. So up arrow, condition.java. Fantastic. Okay. Okay, we're going to give ourselves a little more real estate. We typed in CLS, and then we'll just redo the condition again. The compiler. Then we'll run the program. Okay, let's explain this, right? So what does this mean? 1579. So that number is 1579. Right, this thing right here is called a modulus, right? So how do you read that? You read it like this. So this number, which is number 1. Okay, yeah, like I was saying, this number here, 1579, it's not necessarily meaning it divides by 2, but it goes into 2 how many times? So if you just kind of angle it and say, oh, well, let's see, 2 times, I don't know, 12, 2 times 800, right, equals 1600. Okay, that's too much. So 2 times 2 times, well, actually, no, this is how you do it, right? So 1579 divided by 2, right? So 789. So if you do 789, so 2 times 789, you're left with 1. Okay, so that's what that's really what it means, actually, is this number here, 1579, divided by, or how many times does it go into, how many times can it divide by 2? 789 times, or whatever it is, right? So what it is if there's a remainder, that remainder, like this right here, this exclamation point equals, that means unequal. That's what it means, unequal to. So that number would be unequal to 0, and that's why you have it odd true. It is true. Now let me show you why the other one is it'll make sense in a second here. So let's say, for instance, you have in this guy here number 2, which is 2468. So you go let's see, 1234 times 2 equals 2468. You don't see a remainder there. You don't see like an extra like an extra character. So in that case, meaning like number 2, so 2468 divides into 2 1234 times with no remainder, right? So unequal to 0. Is it unequal to 0? The answer is false. It's equal to 0, actually. So that's why you have the even here. And you can play around with these numbers. So I don't know that there's a, I think, let's try one that is like they're both going to equal even, right? Okay, so I've changed values of number 1 to 4 and number 2 to 2. So basically it's 2 times 2 is 4. There's no remainder, is 0. So unequal to 0? No, it's not. It's actually 0. So that would mean it's false. So that would mean you'd put even here. And how do you really know that, right? I'll tell you. This thing here is called a Boolean expression. And this question mark here means like, okay, if this is true, if this is false. That's not explicitly, said, but that's what that means. The question mark means in this case anyway. So if we play with those numbers, we're both going to see even, because 4 divided by 2 is 2 with no remainder, like this 0, right? Is it unequal to 0? No, it's not. It's equal to 0. So that's false, meaning unequal to 0. False, so that's even. So let's run that. Yep, so both even. Yeah. And you can play around with these yourself, and so you understand it completely. I know it took me a long time to figure it out. Like, what does that mean? Why is that like that? That's Java for you. So I'd like to thank everybody for listening, for watching this video. Please subscribe to the channel, and please push the like button. That's what they always say in the other channels, so please do that. Thanks, have a great day. For the next video here, we're going to be setting up a precedence program, like a precedence.java. So first, let's just code it. Let's change our code here. We'll name our program precedence.java and write the code. So what is precedence? What does that mean exactly? They're just numbers. Okay, precedence is like this. What's going to happen in this regard is first it's going to do the 15 times 2, right? So it's going to do this. It's going to do, let's actually note it. It's 15 times 2, and that equals 30. So that's how it should read. So after it does is times, so 30, right? You take that number now, 30, and then you're going to do the addition. And you're adding actually the two numbers now that were less. So that would be actually 20 now. So it's 30 plus 20. So you're left with equals 50 is what it will actually represent. For the next one here, you have the sum equals 30 less 10 plus 15 times 3. So what it's going to do is it's going to first do the 30 less 10, you're going to get with 20. Then it's going to add the 15 in there. That's going to be 35. And then it's going to multiply that times 3. You're going to equal 105. And for the last one, what you're going to see is it's going to add these two numbers to here. So that's 25. And then it's going to less from 30. So 25 minus 30. For the last one, we see, so this number 30 less 25 times 3. So we're left with 5 times 3 equals 15. So when we compile the program and run it, we should see these outputs. Okay, so let's run the program. Oh, we do. We see it. Fantastic. See the 50, 105, and the 15. So the program works successfully. So thank you very much for watching this tutorial. Please subscribe to the channel and push the like button. Thank you. In this lecture, we're going to be setting up a program in Java for those of you who like networking, right? Basically, they're going to be setting up like an IP address, kind of, sort of, but it's more of, we're just going to call it bits. So it's going to be a bits program, and we're going to basically take the output of like 0 and 1 and be an on off, much like we did before the last video when we did conditionals, or conditions rather. So let's type up our program. Okay, here's our program called, we're going to call it, the program is going to be bits. So it's going to be like a bits.java, right? So here's, I just want to explain this to you, right? So for instance, the integer, we're going to put IP version 1 or IP1, if you will. So the 192. So typically any IP address is 192, 168, etc., etc. Okay, let me explain this, right? So integer, IP1, it can be anything. It doesn't matter what it's named, right? As long as it's not the same name as this one right here. That's why it's 2. Then you have the 192. So what happens is, whatever number you put in here, doesn't matter what it is, what you're going to see is the system out is going to print like a flag. For instance, in the IP range, you might see listed as 192.168.1.1. So the dots in between represents 8 bits. So the flag 8 means there's 8 bits. So each bit in a networking scheme means something. So the 8-bit, which is basically like here bit, that's like 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? So the IP would be, that's 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's an IP address. No matter what it is. Doesn't matter what it is. That's actually a 0. So that's all off. That means it's 0.0.0.0. That's a broadcast? No, that's not a broadcast. Could be, yeah, it could be a broadcast. Well, a traditional broadcast really is everything on 1. If you have all ones, that's 255, 255, 255.255. So let's just play this out a little bit. So just give you a little representation here. So for instance, these bits, these 8 bits here, they mean 8 bits. So the very first bit in the IP scheme, of course we're doing a Java program, but I'm just going to tell you a little bit about networking, if you will. The very first bit stands for 128, or if it's 1 completely, it's 128. It's either on or off, right? Second bit is either on or off. That's 64 or 0. 32, 16, 8, 4, 2, 1. It's not uncommon to see something like this, where you might have not all the, not every bit is on, but not the same in row is on. So that's common as well. That just means this this bit is worth this much. So in our case, 192, so what's going to happen is it's going to turn on, say, for instance, 192. So it's going to do the 128. It's going to do that one. That's going to be an on. That's going to be an on. And then 128 plus 64 is 192. Let's do the math. 128 plus 64, 192. So what you're going to see in the very first example is flag 8 or bit 8, this is 8 right here, is going to be on, which is a 1, right? It'll look like this, really representationally. And then bit 7, or flag 7, is 64. That's going to be turned on as well. So what you're going to see is it's going to look like this. 0 and 0 and finally 0. That's what you're left with. And same thing with 128 and then 1 and then 1. So in our case, 1, it's just going to have the last bit as a 1. This is how every single IP4, IP version 4 IP works in the whole world, no matter what. Every single IP in the world, IP version 4 works this way. So it's 8 bits. So there's 4 times 8, so it's 32-bit. So it's 8-bit, 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 8-bit. And the bits have a number associated with it. It's either on or off. So this is just a demonstration of that in a form of Java program. And since we did the little / thing there, it's not going to calculate it as a program, or it's not going to calculate it. So let's get rid of this. Let's clean up our code a little bit and clean up that a little bit. Okay, and get rid of okay. It's fine if you leave spaces. That's no big deal. Okay, and finally here. Good, awesome. So looks like good. Everything looks fine. It's either on or off. So again, this means the flag 8. So that's what you're going to see actually. So system out equals, or system out is the flag, which is just going to be a flag. The IP1, so that's this version. And this little thing here, this little and symbol, right? That means, so that means that's an and, right? Let me just draw that. So in our case, the 192, okay, and it's just represented by and the 128. So basically both bits are 1. So what you're left with is this. So it looks like this, right? So greater than 0. So 1 and 1, that's 1, is greater than 0. It looks like this. Is 1 and 1 equals 1. So there's bits here, that's a 1. So what you're left with is 1. Is that greater than 0? And here we're left with, if it's true, turn on. If it's false, turn off. So 1 is greater than 0. True. So true. 1 is greater than 1 is greater than 0, true, that's on. In this case here, it'd be 1 is greater than 0, that's on. Well, you might be asking yourself, how on earth does it know flag 8? How does it know that? How does it know that? Well, because the actual flag, so the flag is an actual program, right? So it's an actual program. So it's like it knows the point of, so I can probably actually just move these out of order and be fine. Matter of fact, let's do that. Let's put 8 at the very bottom here. So that way you see it's the flag itself. It's actually the flag. So what's going to read is it's going to 1 and a 1 at the end, right? So that tells you that this word here, flag, it's like, okay, flag position number 7. Oh, okay, I know it's this one right here. Oh, flag position number 8. Oh, I know it's that one right there. So let's run our code here. Compile it first, actually. Compile. So compile. Okay, perfect. Now let's run the code. And let's see here. Okay. All right. Oh, I didn't save it. Excuse me. Okay, it's been saved. Let's clear the screen. Run it again. Okay. And then we'll run the program. All right. So same thing here. Flag 7, it knows, okay, I know flag 7. Yeah, that's the second position. 6, right, and 8. Okay, I know it's on because it's down. You know, it knows the position, right? The same thing here as well. So
at the very bottom, I flipped them. So what you have is you have 1 through 8 instead of 8 through 1, just to show you the difference, right? It doesn't really matter. It knows, okay, flag 1 equals this. So just what I wanted to allude to is this, basically. The flag, so 192 and 64, if they're both 1, that's 1. 1 is greater than 0, so that's true. Yep, put a true. If it's false, put a false. And since the program knows, okay, I know there's a bit here, meaning flags like, okay, position number 7, there's something there. Okay, good. And there's something there, 64-bit. Yep, okay, that's a 1. Good. Okay, flag 6, there's nothing there. I mean, sorry, there's something there. That's a 192, and there's nothing there in the 32-bit. So that's 0. So 0 is greater than 0. That's false because greater is not greater than 0. So that's false. That's why it's off. So play around with these programs. It's kind of cool, actually. You know, a little bit of networking here, basically in the coding realm or Java realm, and just have fun with it, right? So I'd like to thank everybody for viewing this tutorial. Please like the channel, or please subscribe to the channel. So thanks again. Have a great day.
In this lecture, we're going to be creating a else program in Java. First things first, let's call our class, and we'll call it else. Else? Else. Yeah. E-L-S-E. Okay. And we're going to save that as a Java. Let's see here, class dot, no, we'll call it else, capital else dot Java, and it's okay, it's going to put it there, that's fine, dot Java. Okay, alright, so we're going to put our what do you call it, not the container, because this is a container, but the main method, and then finally the statement. So our main method is going to look like this. Okay, so we've identified our main method, and now we're going to input our statement. In our statement, we're going to identify, so an integer is going to be, I'm going to call hours. Hours, A-R, well, let's see week. Integer is a week. Okay, so the week has 168 hours, right? So we're going to do equals 168, right? Yeah, little colon there. So we're going to put so we're going to identify the if statement. So if, let's call week, okay, is equal to 168. Okay, then let's see, we'll do another bracket. Okay, so you got the section here. So if week equals 168, which it does, right? Then you're going to do system dot out, not out of memory. That is not right. Actually, it's out, and it is print line, right? Okay, so we're going to put this hours in a week. Yeah, how about that? Hours in a week. Okay. Okay, we're going to do a plus symbol after here. We'll do plus, and we'll put week, right? Then we will close it up. So that's our statement. So let's save this and let's run it, compile it. So what should happen here is I'm declaring the integer of week. So first things first, you have to declare the integer. Integer week equals 168. So if week equals 168, then system out print line hours in a week plus our week, right? So what we should have is we should have 168 or hours in a week, and then 168 after that. Now let's run our code. So we're going to java.exe. Then we're going to do else, yeah, .java. We're going to run the program. Oh, okay. Looks like I have a conflict here. I should not put that in there. So week equals, what should I have after that? Okay, that's wrong then. Let's see. I got to put something else other than equals. Let's actually put day here. So day, if day is less than, no, that's wrong actually. I'll go week. If week is less than 24, greater than 24? Let's say greater. Greater than 24. There you go. That's perfect right there. If week is greater than 24, let's save it. Let's recompile our code. And let's see here. So java.exe, and we'll do the else program. Run that. You could really play around with the numbers all you want, right? So the code really, the example is just an example. So integer week equals 168. Those are hours, right? If week is greater than 24, which it is, then system output equals hours a week. So you're outputting this text here plus week. So you could make it put this anything really, but the it's outputting the week number here. So hours in a week equals 168. And you could use this for a number of things, such as, let's say for instance, freezing. If the temperature, so this could be like temperature, temp, right? Temperature, right? Temperature equals 212, boiling point, water boils, or water freezes. I think water freezes at 32 degrees Fahrenheit, right? 0 degrees centigrade, yeah. So if temperature is greater than 32, then no freezing, no freezing, right? Plus temp. Okay. Okay, let's see. 40. If it's greater than 40, actually, let's change less. If it's less than 40, because that's actually more accurate. So if it's less than 40, then print this, no freezing. It is less than 40, so what you expect to see is no freezing plus temp, or no freezing plus 32. So let's do this, Java, yep, so that one. And then we'll run the program. Okay, yep, okay, no freezing 32. Excellent. Okay, I'd like to thank everybody for viewing this tutorial. Please subscribe to the channel. Please like the video, like the channel. And thank you again, and have a great day. In this lecture, we're going to be actually setting up a float, or a convert, if you will. So we're going to convert numbers to weeks. So in this case, we've already written our code in Java on our program, convert.java, that's our program. So we've established our method and our system output basically. So I have your float, which your days float equals 365.25. You have your string, which specifies 52 weeks. You have your integer, which is days integer. So the integer, you have to define, you have to be able to take numbers and be able to put it into a pattern. So it wouldn't really work if you did like 365 divided by 52. It really wouldn't work that way. And plus, you don't want to do that for a bunch of code. You'd have to do it every time. So in order to do that, in order to alleviate that, writing more code, you would just identify your float, your string, and then put an integer noting that days float. What does it mean? You know, and then your integer with your weeks integer, So basically, you know, you need to be able to kind of a three-step process, two-step process really. First, you're identifying your float, then you're identifying your string 52, then you're identifying your integer, then your second integer, which is your weeks. You're taking your string and converting it to an integer essentially, and then now you have your program. So integer week equals days integer divided by weeks integer. So the system, when it prints it out, what you're going to see is probably 7. So it'll take 365.25 divided into 52, which equals 7. So let's do that. Let's compile it first of all. So we'll do javac.exe, and then this is convert.java. It's not a class. Okay. All right. So we've ran our program, and now our program is ready. So now what we're doing is we're going to run our program. So we'll do java.exe, then we're going to do convert. Okay, get rid of that. Okay, and what you're left with is days per week is 7. So what happened here was this. Just to reverse engineer it, you had a week. So I'm identifying days per week, which is week. So my integer of week is days integer, which is, well, it's 365 really, and then divided by weeks integer, which is 52. So if you kind of reverse engineer it, this is this, these two lead to these two, which and therefore lead to these two. Okay, so this is just a quick little tutorial on converting in Java programs. Thank you for watching this video. Please subscribe to the channel and like the video if you desire. Thanks. Have a great day.